So this next problem here is one of the few times that we actually get to do some algebra in this class, so I say we enjoy it. So they want to know what is the minimum number, see that? Minimum number of people that must be polled to ensure that the sampling distribution is normal. Okay, so let's remind ourselves here of this fact right here. To be normal, we have to have it, hold on, I want to make it larger, but not that large. Okay. We have to have it so that n times p times 1 minus p is greater than, technically, or equal to 10. Okay, but n is what we're asking about. We don't know what it is. We know that p is 0.98. We know 1 minus p is 0.02. And we want that to be greater than or equal to 10. Okay, so that's n times, and then you can multiply these with your calculator or with Excel. Equals 0.98 times 0.02, and you get 0.0196. 0.0196. Okay, so n must be greater than or equal to 10 divided by 0.0196. You divide both sides by that. So let me find that with Excel. Equals 10 divided by that answer, 510.2. So that means n must be greater than or equal to, oopsie, 511. Can't be 510.2. You can't go any lower than 0.2 part, right? So you can't go to like 510, because if you did, you wouldn't get normal. It wouldn't work out to be greater than or equal to 10 when you multiply it. So you have to round up. So note, must round up for these kind of problems when they're asking for sample size. And that's going to continue, by the way, in Chapter 9. You're going to have to do sample size calculations there. Again, you will round up. You can't go any lower than the 510.2. So you have to round it up to 511, because you can't get 0.2 of a car. Okay, in a random sample of 750 drivers, what is the probability that more than 98.5% of them are speeding? And I drew a lovely normal curve. Here it is. You can't see it, but 0.98 is right down the middle, right? The computer won't really show that very well. And then I want 98.5%, right? So I will draw a graph of that. Hold on one second. It's an integral between that and this one from 0.985 to, it doesn't matter, forever, at the graph. Okay, there it is. So that's what I'm looking for. I'll even paste it into my, oops, I just pulled up my email. I didn't really want to do that. All right. Okay, there it is. Now, I want to find this area. It's a right tail area again with the calculator, with Excel, excuse me. So Excel is a type of calculator, right? All right, so let's do this. Right tail area for part C. It's going to be equal to 1 minus norm dist. Norm dist wants x, which is 0.985, the mean, which was 0.98. The standard deviation, I think it's just going to be easier if I reference that cell right there, okay? Because that's where I found it before. True. I mean, it's either that or you could type 0.00511, whatever, in there. But I mean, why bother when I have it all calculated out? So that area that I just got right there is 0.164. 0.164. Oh, I think it was. Yep. Okay, what about this one? In a random sample, what is the probability that less than 728 of them? Ooh, okay. Hold on, we're dealing with proportions here, right? So the first thing I'm going to have to do is make a p hat out of what they just gave us. Oopsie, p hat. I can do this. There it is. Equals x over n, which is 728 over 750. So they gave you a whole number, but that's not useful to us. We need to make a proportion out of it. Equals 728 divided by 750. It's 0.97066. Okay. All right, I've started that problem, but we're not done with it yet. I'll be back for the next part.